Algebraic proofs. You saw algebraic proofs back in Algebra 1. You solved equations and you listed each of the properties or laws of algebra that allowed you to complete that step. You're going to see algebraic proofs again this year in geometry, and they'll show up for a third time in Algebra 2. So this whole idea is not going away. How do I complete an algebraic proof? All right, we're going to begin with some properties of equality. These are all properties that you have seen before, all right, but you should make yourself note cards to ensure that you remember them and you're practicing these names on a regular basis. The addition property of equality allows you to solve this equation. What do we do to solve this equation? Correct, you add 6 to both sides. So this is called the addition property of equality. If A equals B, then A plus C equals B plus C. We usually abbreviate this ADD for addition, for property of, EQ for equality. Now I know some of your teachers in Algebra 1 may have taught you to say POE for property of equality. My only concern with that is a lot of times students don't remember what POE stands for. If you actually write out prop of X, property of equality, you're more likely to remember what it is you're talking about. The subtraction property of equality allows you to solve this equation. What do? That's right, you subtract 6 from both sides. So A equals B. A minus C equals B minus C. Now subtraction has to be abbreviated SUBT, prop of equality. The multiplication property of equality allows you to solve this equation. And what do? We multiply both sides by 2. So A times C equals B times C. This one would be abbreviated MULT, property of equality. The division property of equality allows you to solve this one. What do? Correct. Divide both sides by 2. So A divided by C equals B divided by C. Division, DIV, property of equality. The distributive property of equality, this can occur across addition or subtraction. And remember, we are sharing that multiplication. So A times B plus A times C for this one. DIST PROP. Next up, we have the substitution property of equality. If A equals B, then A may be replaced by B in an expression. And we just abbreviate this one sub for substitution. Whoops, sorry. I should have highlighted the substitution property of equality for you, because you should make a note card. Now, the last 3 you saw in Math 8 and you saw in Algebra 1, but people have a tendency to forget them. Reflexive, symmetric, and transitive are 3 words that you're going to see in at least 4 different ways, 5 different ways this year. So we have it for equality. We're going to talk about segment congruence, angle congruence, congruent triangles. So 4 different ways. The reflexive property of equality says that any number equals itself. And we usually reflexive property of equality. Wasn't very useful at all in Algebra 1. In fact, it was pretty much a waste of time. But we will use this idea of reflexive when we're proving triangles are congruent and a triangle maybe shares sides. The symmetric property of equality allowed you to handle this situation in Algebra 1. That is horrible mathematical grammar. You can't leave your answer that way. You need to flip it over and put the variable first. So this said if A equals B, then B equals A. So symmetric property of equality. Now I always had a hard time remembering the difference between reflexive and symmetric. So I imagine that there's a line of symmetry, and I'm actually flipping over between A equals B and B equals A, and then I remember that reflexive wasn't useful. Transitive. Transitive property should remind you of what from the laws of deductive reasoning? The law of syllogism. If A equals B and B equals C, then A equals C. So transitive property of equality. All right, so in geometry, we are going to focus on the two-column proof. There are other ways to write proofs. You can write paragraph proofs, complete with spelling and grammar and nice pretty sentences. You can do flow proofs, which involve boxes and arrows. There are even indirect proofs, which is an honors topic. But for this class, we are going to focus entirely on the two-column proof. Now, for your assignment, I've already drawn a nice table for you. But when you are given a blank space, what you need to do is draw it in this big T. On the left side, we're going to list our statements. And on the right side, we're going to list our justifications. Okay, so we need to title each of these columns. The statement, or steps, and the justifications, or reasons. Okay, each and every one of these rows absolutely must be numbered. And step number one, statement and justification number one, is always what you are given. You should never, ever, ever leave a proof blank. Everybody can do this much. Even if you don't know how to solve the proof, you can at least set things up. And that's usually worth 20% of the points. Can you set it up? All right, I do have a typo right here. This should be a 2. So what is our first step in solving this equation? Add 1 to both sides. So 4x equals 8. And adding 1 to both sides is the addition property of equality. The next step, divide by 4. So x equals 2. And that's the division property of equality. Notice every row is numbered. 1, 2, 3 under statements, 1, 2, 3 under justifications. When you do a proof, your rows should come out even. So if you ever have to use 2 lines for something, you should skip a line on the other side of the proof so that you stay nice and even. All right, let's set this sucker up. Let's draw our T. Let's put in our headings. Let's write our given. Okay, at this point I want you to pause your video and try the rest of this on your own. All right, check your proof. Did you number every row under statements? Did you number every row under justifications? Did you subtract first? and then multiply second. I want you to try the next two on your own. We do need to modify this one. Take out that x, and the answer is really going to be 2/3. Take a moment and try them. Pause your video. Okay, let's take a minute to look at both of these. The first one I asked you to work on involved the distributive property. Really watch your integer rules as you're doing that, making sure, because once you mess up the integer, right, then you mess up the problem and it's not going to work out. The third one on this page was really interesting, and it was interesting in step 3. At step 2, we have negative 7x minus 14 plus 4x on the left side. And we need to combine like terms. We need to combine the negative 7x and the positive 4x to get negative 3x. So I've actually put this step, the justification, in red because I call it combining like terms. Some teachers and some textbooks will call it simplify. It's completely up to you which word you use. When you look at that and you know you need to put the x terms together, what do you call it in your mind? And use that word, either combine like terms or simplify. All right, at this point, you should write me a summary. What do you have to have, what do you have to have in a 2-column proof? How do you set it up?